You are standing beside an automotive production line in China. A worker reaches into a container, lifts a component, turns toward the moving car body, and places it exactly where it needs to go. A few meters away, another worker is learning the same job. Except this one has no face, no lunch break, no salary, and when its battery runs low, it can eventually change that battery itself and go back to work. This is UBTECH's Walker series, one of several Chinese humanoid robots already being tested or deployed inside factories operated by companies including BYD, Geely, NIO, Foxconn, and FAW Volkswagen. The jobs are still narrow: material handling, sorting, inspection, simple assembly, moving containers, plugging connectors. These machines are nowhere close to replacing an experienced factory worker at everything. In fact, UBTECH has acknowledged that its current industrial humanoids can operate at only around 30 to 50% of human efficiency on many tasks. So why should anybody worry? Because while engineers are still trying to make humanoids work like humans, China has already started solving a different problem: making them cheap. Unitry Robotics currently lists its R1 humanoid from about $4,900 before tax and shipping. The more capable G1 starts around $13,500. In 2024, that G1 debuted at 99,000 yuan. Then Unitry launched the R1 in 2025 at 39,900 yuan. By 2026, the entry-level price had fallen again. Think about what just happened. In roughly 2 years, a technology that looked like a six-figure research project began appearing on a manufacturer's website at a price below many used cars. Now, a $4,900 R1 is not a $4,900 factory worker. That distinction matters. It may need different hands, sensors, computing hardware, safety systems, integration software, and industrial support before it can do useful production work. A robot that performs backflips on YouTube is not automatically qualified to assemble a gearbox for 8 hours. But the sticker price reveals something more important. The hardware is moving down a cost curve, fast, and factory economics are extremely sensitive to cost curves. A company does not actually care whether a machine looks futuristic. It cares about one calculation: how much useful work can this machine perform for every dollar we spend on it? For decades, industrial automation answered that question using robots that did not look remotely human. Walk through a modern car factory and you will see giant orange or yellow robotic arms welding, painting, and lifting heavy parts inside fenced-off cells. They are extraordinarily fast, extraordinarily precise, and incredibly bad at leaving their cage. A traditional industrial robot is usually installed around one predictable task. The factory is designed around it. Fixtures position the part. Conveyors bring materials to exactly the right location. Safety barriers keep humans away. That is perfect when you need to perform the same weld 2 million times. It is less useful when the job involves walking 30 meters, opening a container, selecting different objects, using equipment designed for human hands, and then moving somewhere else. That is where the humanoid begins to make economic sense. Factories already contain one incredibly versatile machine: the human body. The stairs are designed for it. The tools fit its hands. The shelves match its height. The aisles fit its shoulders. A humanoid promises something industrial automation has wanted for decades: a robot that can enter an environment designed for people without forcing the factory to rebuild everything around the robot. That sounds simple. It is brutally difficult. Walking is difficult. Picking up a flexible cable is difficult. Recognizing the correct part when someone leaves it at the wrong angle is difficult. Humans make thousands of tiny corrections without thinking about them. Robots expose everyone. At recent Chinese factory trials, Walker robots have been trained for tasks including quality inspection, material handling, vehicle badge installation, fluid filling and manipulating charging connectors. At NIO, UBTech says Walker was used in final assembly and inspection. At Zeekr, multiple robots have trained on logistics and manufacturing tasks. Dongfeng Liuzhou announced plans to deploy at least 20 Walker S1 robots across parts of its vehicle production process. 20 robots do not replace a factory. They barely fill one corner of one. But this is where the economics become strange. The robots do not need to become better than the best worker. At first, they only need to become cheap enough that being worse is tolerable. A human employee is not purchased once. Labor is rented every hour. Salary, benefits, overtime, training, recruitment, turnover, safety costs. A robot reverses that equation. The expensive part comes first. Then the business tries to spread that cost over as many productive hours as possible. Recent analysis cited by J.P. Morgan estimated that humanoid robots in manufacturing and logistics could eventually operate around $10 to $12 per hour in some scenarios, compared with roughly $30 per hour for the U.S. warehouse or manufacturing labor being modeled. Those numbers depend heavily on utilization, maintenance, and performance, and today's robots are still less productive than people. But notice what happens when the hardware price falls. If a robot costs $120,000, a factory manager needs extraordinary confidence before buying hundreds. At $30,000, the conversation changes. At $13,500, it changes again. At $4,900, engineers start buying them simply to experiment. And experimentation creates data. That may be China's most important advantage. A humanoid does not learn factory work because someone writes one perfect line of code. Increasingly, developers want robots to learn from demonstrations, teleoperation, simulation, and real-world repetition. Pick up this box. Place it here. Now the box has rotated. Try again. Now someone blocked the aisle. Recover. Every failure can become training data. Cheap robots make failures cheaper, and China can manufacture a lot of them. In 2025, China produced roughly 12,800 humanoids according to one industry analysis, representing the overwhelming majority of global output. By the first half of 2026, Reuters reported Chinese companies had delivered more than 40,000 units as production accelerated dramatically. Many are not doing commercially valuable factory work yet. Some go to research labs. Some go to government-supported training centers. Some are used for demonstrations and entertainment. That is important because the current humanoid boom contains plenty of hype. Industry observers have questioned how much demand is genuinely commercial rather than policy-supported. But even subsidized demand does something. It fills factories. It creates suppliers. It trains engineers. It increases component volume. And volume attacks cost. Now take the story to Hangzhou. This is where Unitry was founded in 2016. The company first became famous for four-legged robot dogs. Those machines forced Unitry to solve many of the same problems humanoids need: high-performance electric motors, compact actuators, balance, motion control, batteries, and durable joints. Then Unitry moved upward. 2 legs, arms, hands, humanoid bodies. What separates Unitry from many Western robotics startups is not that it possesses magical artificial intelligence. Its founder, Wang Xingxing, has been unusually cautious about that. In August 2026, he said the industry's true ChatGPT moment, when robots can understand instructions and reliably perform most tasks in unfamiliar environments, could still be 2 to 10 years away. That sounds surprisingly conservative from the man selling $4,900 humanoids, but it reveals the strategy. The intelligence can improve later. First, make enough bodies. And China is unusually well positioned to manufacture those bodies because the humanoid robot is beginning to collide with another industry China has already scaled aggressively: electric vehicles. Look inside a humanoid. Motors, power electronics, battery packs, precision bearings, sensors, controllers, machined aluminum, permanent magnets. Many of these components sit beside technologies already produced for EVs, drones, industrial automation, and consumer electronics. McKinsey estimates China has significant production strength across several critical robotics components and operates dense humanoid supply clusters around places such as Hangzhou, Ningbo, Shenzhen, and Suzhou. China also installed roughly 295,000 conventional industrial robots in 2024, more than half of global installations that year. This creates an advantage that is easy to underestimate. Suppose an American robotics startup redesigns a joint. It may need a new motor supplier, a custom gearbox, a machined housing, a revised circuit board. Then prototype parts have to move between companies. Every supplier adds lead time. Every custom part adds cost. Every low-volume order produces an ugly quotation. In China's industrial clusters, robot makers can draw from suppliers already manufacturing similar components for cars, automation equipment, and electronics. The robot industry does not have to build every factory from zero. It can parasitize an industrial ecosystem that already exists. More than half of some humanoid components can potentially leverage existing new energy vehicle supply chains, according to Chinese industry estimates, helping manufacturers avoid major new capacity investment. And then scale begins attacking the most expensive part of the robot: the joints. A humanoid might need 20, 30, or more actuated joints. Every shoulder, elbow, hip, and knee requires motors, bearings, reduction gears, encoders, controllers, and structural parts. McKinsey estimates actuation can represent roughly 40 to 60% of a humanoid robot's bill of materials. Make each joint a little cheaper, and the savings multiply across the whole body. That is why Unitry's falling prices matter. The company is effectively doing to humanoid hardware what Chinese manufacturers have repeatedly done in batteries, solar panels, drones, and EV components. Take something expensive, standardize it, build supplier competition around it, increase volume, cut price, repeat. And this is where Western robotics companies face a strange problem. Boston Dynamics may have one of the most technically impressive humanoids in the world. Figure AI is deploying humanoids into industrial environments. Apptronic has worked with Mercedes-Benz. Agility Robotics has built Digit for logistics. Tesla is developing Optimus and has talked about eventual production costs around $20,000 to $30,000. But most Western humanoids are still not products you can simply order online at commodity-like prices. China is trying to make the hardware ordinary before the software is extraordinary. That can change who wins. Because once robots become cheaper, a factory does not have to identify the perfect use case before experimenting. Buy 10. Put 3 in logistics, 2 in inspection, 1 beside a CNC machine. Let 4 collect training data. See what survives. A $100,000 machine must justify itself. A $10,000 machine can be allowed to learn. And China has something even more valuable than cheap factories. It has factories that desperately want automation. The country is still the manufacturing center of the world, but its population is aging and its working-age population has been shrinking. At the same time, manufacturers are competing in industries where margins can be savage. Electric vehicles are the clearest example. Chinese automakers have spent years in price wars. Saving a few $100s per vehicle matters. Improving utilization matters. Running equipment longer matters. That creates a natural laboratory for humanoids. UBTECH's Walker S2 takes this logic to an almost absurd conclusion. The robot uses a dual battery system and can autonomously replace its own battery in about 3 minutes, allowing the company to market it for continuous operation. Think about why that feature exists. A human worker goes home. A robot investment makes more sense when it does not. Of course, 24/7 capable is not the same as 24 hours of useful productive work. Motors wear. Gearboxes fail. Software freezes. Hands drop things. Factories contain unpredictable humans. Reliability is still one of the industry's biggest unsolved questions. And those limitations protect workers more than robot demonstration videos suggest. A human can notice a spilled bolt, step around it, answer a supervisor, grab a different tool, and return to the original job without a software engineer standing nearby. Current humanoids are still embarrassingly easy to confuse. China has not solved general-purpose robotics. Nobody has. But factories do not require general intelligence to automate labor. They require thousands of narrow tasks. Move this box. Inspect this panel. Feed this machine. Carry this tote. Connect this charger. If humanoids can absorb those jobs one by one, displacement does not arrive as one dramatic event. It arrives workstation by workstation. That is why the title of this story is slightly deceptive. China's humanoids may not replace factory labor all at once. They do not need to. Replace 5% of tasks. Improve the robots. Then 10. Then 20. Every deployment creates more training data and more component orders. Every component order reduces cost. Every cost reduction makes another task economically viable. That feedback loop is the real threat. Now return to the production line. The human worker is still faster. For now. He reaches into the container without calculating joint angles. He notices the part is upside down. Corrects it. Moves on. The humanoid beside him hesitates. Its hands are clumsy. Its movements are slower. If all you measure is today's productivity, the human wins easily. But that may be the wrong comparison. The machine standing beside him is not competing only against him. It is competing against next year's cheaper machine, and the one after that. China has already pushed one humanoid platform below $5,000. It is already putting industrial models into car plants. It already has the supply chain to manufacture motors, batteries, electronics, and precision components at enormous scale. The robots are still learning how to work. The factories already know how to make robots cheaper. That order may turn out to matter more than anyone expected. If you like documentaries about the hidden economics behind technologies rewriting entire industries, subscribe. And tell me this. If a humanoid became 80% as productive as a human worker, but cost a factory only $10 an hour to operate, how long do you think companies would keep choosing the human?